Y'all had an okay spring break. I'm glad to be getting back to work with you guys. Um, just be sure to look over the email because we do have some major changes that are coming our way. Most of them are beneficial, leaves us a little bit more flexibility. One of those, for example, is our mini projects. So, as you know, our mini projects won't be collected anymore, but that doesn't mean you still can't reach out to me to get feedback and make sure that they're good to go and that you got everything right. The exams are still going to come off of our lecture notes, our homework, and our mini projects. So, it's still really important to do well on them. The way they'll work from now on, though, is I will post a video of myself going through them. I won't go through the entire thing and give you an opportunity to work on it yourself. And then later this week, I will post the key. Okay, so if you have questions, though, of course, you just send me an email and we'll go through it so that you feel good about it before the key comes out. So let me switch this over. So here's our mini project 5. Our plan today is just to go through it. Like I said, I'm not going to do everything. I want you guys to be working on it on your own, but at least let me walk you through what needs to be done. So in part one, we're identifying the different types of data sets that are described here in these 5 pieces. Each of these data sets are either considered qualitative or quantitative. Remember, go back to your notes to check out the differences between the two. Think qualitative as like quality. It's almost like a descriptive way of kind of telling us some more information about the data set. Quantitative comes from that root word quantity. It has a numerical measurement that's absolute. It's not really an opinion. It's more of something that has one measure and it's not really disputable. So those are kind of 2 ways of looking at the differences between qualitative and quantitative. So going through these, you should be able to answer some of these. The age of your car is not a subjective thing, right? Whether you're measuring it in years or in months or in minutes, it's an exact number, right? And so I would consider the age of your car to be a quantitative or a quant type of data set. The color of the sky is a really interesting one. I'll let you guys kind of just work on that. I would certainly say that that's a qualitative measure, that the color of the sky is a little subjective to 2 different people, may see it 2 different ways, particularly myself because I'm colorblind. You could argue, though, that color of the sky is a quantitative measure. We mentioned this in class right before I left for the rest of the semester. Um, we talked about the fact that the color of the sky is actually you can go on a program and write out the combination of red, yellow, and blue ratio that's needed to generate a particular color. So there is some absolute truth to color of the sky, um, but in truth, really, I think that's just kind of your opinion. Whether bathwater feels hot or cold to you. That's how it feels to you, right? It's not the temperature of the bathwater, as in D. So you can see the difference between C and D, right? Whether it feels hot or cold to you is kind of your opinion. That's qualitative data. Whereas the temperature of the bath water is an absolute number, right? That's an objective value. We would consider that to be quantitative data. On we go. So in part two, what we're doing is we're looking at a lot of different numbers here, this massive data set that gives us the hours that a student studies and then their grade in the class. And this table we can see here on that second page, if you're working on Mini Project 5 at home and you've printed it out, it may be good to have these 2 pages separate, the back side of page 2 and then the front side of page 3, which I'm going to attempt to squeeze into this page also. Let's see if I can do that. And this page as well, right? You want to keep these 2 side by side so that it's easy for you to go ahead and label and graph what you need to do in part 2. So in part 2, we have hours studying. This is the independent variable, or what we refer to as the X variable. And then the grade that a student earns in the class, we're going to refer to that as our Y variable. And what we want to do in the very beginning of this is look at all of this data, and then on our graph over here, we want to label all of these as ordered pairs. And before we do that, we need to label our axes. So we want to create this scatter plot. Remember that the x-axis is down here. It's the one that's going horizontal. In this case, we said that the x-axis represents hours studied. So I'm going to have hours studied here on the bottom, and then on the y-axis we have grade. So over here I'm going to put grade. And then it's also important for you to get a good scale. So you can see that these numbers fluctuate between 0, and it looks like the highest one in here is about 90. And in terms of the grade, the lowest value we have is around the 40s, and it goes all the way up to almost 100. It looks like we have one in here that's as high as 97. And so what we want to do is we want to look at our chart here and figure out how many lines we have and how we want to break this thing up. So I can see here I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines, or this grid is a 10 by 10. So because our maximum values are 100, it may be best for us to go by increments of 10 along our axes. So I'm going to say 10, 20, 30, and so on, all the way up. 50, 60, 70, 80, 90, and 100, all the way at the top. Our studied also is a very similar range, and so I'm going to do the same thing. I'm going to make that same scale where each one of these lines is worth 10. So 0 would be right here, all the way on the corner here would be where 0 is, and then each line that I go across, I'm increasing by 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90, and then lastly 100 all the way over on the end. Okay, now that we have this thing labeled, what we're going to do is we're going to look at each one of these ordered pairs and we're going to plot them, an x value and a y value. So our first one here tells us that their x value is 90 and our grade is 96. So in hours studied, I'm going to come over here to where 90 is, and now I want to line that up in the y value with 96 in the grade. And so just give it your best guess. Remember that this is 90 right here, and at the very top is 100. So I assume somewhere around the middle is about 95 or so. I'm just going to give it my best guess and say, oh, maybe 96 is about right here. In between, remember, 90 here, 100 here. So a little bit more than halfway up is where I'm going to put this dot. And again, remember that I'm all the way down along the x-axis at 90, right? 90 on the x and 96-ish. Put a little line over here where I think 96 would be. And 96 in the y would give me this point right here. You're going to continue to do that for all of these points, right? I'm going to have one at 14 in the x and 65 in the y. And so I'll just quickly do that one also. Maybe 14 again in between 10 and 20 somewhere. And then I want to go up to 65. And so I'm going to guess that it's maybe somewhere around here. 14-ish, we'll say, and then up to in between the 60 and the 70. And again, give it your best guess, okay? On your own, I want you to complete this entire table, okay? And I'm going to pause this for a second and let you work on that. I just realized you could obviously have just paused the video too. That would have made a whole lot more sense. So if you pause the video and finish filling this thing out, awesome. If not, that's okay. On the back side, we want to graph the line of best fit. The line of best fit is given to us in here, and it tells us that the relationship between the hours that we study and the grade is given to us by this equation right here. Remember that the hours studied is the x variable and the grade is the y variable. So this is the same thing as saying y equals 0.6 x plus 47. 0.6 isn't like the best way of writing this in terms of graphing the line. In terms of finding algebraic answers, it's really nice. But I will tell you that 0.6 is the same thing as 3 over 5. And so it may be easier to graph the line y equals 3 over 5x plus 47. So this is what we want to graph. Remember that the y-intercept is our value that's all by itself over here. I'm going to write that as 0, 47. This is where we graph our first point in the y-axis when we want to graph a line. And then we also know that the slope here is 3/5, which means as we go from one point to the next, we want to go up 3 units and then right 5 units to label our next point. So let's go ahead and graph this thing. See if I have a different color. So the first thing that we want to do when we want to graph the line, and again, at this point, you should have lots of points graphed on your plot, okay? Your scatter plot should be completely full, and there should be kind of a bit of a pattern in there. Do all the points connect into a perfectly straight line? No, of course not. But do they fit kind of linearly? Do they show us that there's some increasing linear pattern? Yes, they should. And remember that our R value for this, when we graph this line, that the R value was, again, the correlation coefficient, 0.91. That is very strong. So when we graph this line, our points better be very close to it, or otherwise something is wrong. Again, it's not going to make a perfect line. R is not a perfect one, but a really high number like 0.9 tells us that the data should fit pretty closely to the line. We want to graph the line by first starting at the y value of 47. So we're going to go to the y-intercept at 47. Remember, here is 40 and here's 50, so I'm just going to give it a good guess somewhere maybe like around here. Oh, my pen's dead. Awesome. New pen. Of course, I have like 30 pens, and none of them seem like they want to be the one I want to use. Trusty pencil. We're going to go with pencil. Okay, so 47, I'm going to guess it's probably just about right here on the y-axis. And then from there, I want to go up 3 and over 5. Now, it's really hard to see where 3 is and where 5 is, but remember that going up 30 and right 50 is the same ratio as 3 and 5. So if you want, you can use these little boxes as a unit 1, for example. So what I'm going to do is from here, I'm going to go up 3 of these boxes. So here's 1, 2, 3, and then I'm going to go over 5. 1, 2, 3, 4, 5, and I'm going to label myself a point right here. I could continue this process. I could go up 3 more, 1, 2, 3, and over 5 again, but you're going to see that I'm actually off of the page if I do that. To graph the line, I only really need 2 points. So I have my point, the y-intercept right here, and I have this other point that I applied by graphing the slope. Remember, I went up 3 over 5. I really went up 30 and over 50. But you could go up 3 over 5 and make a small point over here and give yourself the same line. Now what I want to do is I want to connect these two. So I'm going to grab a ruler or an index card or the edge of another piece of paper or something, whatever I can find. Literally, what can I find? Here we go. Or one of your old mini projects that I wasn't able to pass out to you. And what you want to do with this is you want to connect it by making some sort of a straight edge. Actually, this will work right here. Oh, I found an envelope, actually. That's going to work just great. Got to be resourceful in these times. So I connect my line. It should look something like this. And again, this is what's called the line of best fit. This is the line that models how a student would do on average if we know how much they study in terms of hours. We can predict what their grade is going to be. Remember that when you plot the rest of your points, they should be scattered all around this line. Some of them may land right on this line. Some of them may be a little below this line. As we can see, some of these values may be a little bit above this line. But they should all be fitting somewhat in a trend over here. If you got a bunch of points that are like way down here, something is up. Probably your X and your Y values have been switched, okay? So just be careful with that. Now that we've graphed the line and we have a couple of our plots pointed, we can go through and we can start to answer some of the questions that they ask us in part 2. We graph the line of best fit, so we took care of question A, 2A. And then we go to 2B, and it says using the given model, determine a student's grade in the course if they study for 70 hours. So this is where we're going to use the process of equation and plugging in that expression stuff that we talked about as well, where we want to evaluate. This is what we're doing now. So we have 70 hours here. Remember that hours is an X value. And they want to know, determine a student's grade in the course. And so what we're looking for is a Y value. We don't know what the Y value is, but we know that the X value is 70. And so that's what we're going to plug in. And so we can say that Y, or grade, if you want to use this equation right here, that's fine too. Grade is going to be equal to 0.6 times 70. Don't forget to add 47 to that. We can simplify. 0.6 times 70 is 42, plus 47 tells us that this student who studied 70 hours got an 89 grade. And so this is how the line allows us, or this equation of the line allows us to predict what's going on. And we could go back over here to our graph, and we could find out where that point was, right? We could say, okay, here's where a student studied 70 hours, and the student scored approximately an 89 on the exam. So I'm going to go all the way up on this line to 89, which is really, really close to 90. And what do you know? That's a point that's on the line exactly. Okay, so that's the whole idea of this, is that it allows us to predict certain values based on either hours studied or what the student's grade was. 2C asks us to go the other direction. It says, using the given model, determine the number of hours a student would need to study in order to earn a grade of 72 in the course. Don't let the percentage throw you off. Don't call that 0.72. The grade, the unit of grade is just percent. So that's what they earn. Just think of it as a 72. In other words, we want to plug in 72 for grade, and we're going to work backwards, and we're going to solve for hours. So I'm going to have 72 is equal to 0.6 times hours plus 47. And I'm going to solve this equation for hours. You could have also just put a variable in here like x. That would have been fine too. Remember how we solved this for x. We want to get rid of our 47 first by subtracting from both sides. Remember that 0.6 is being multiplied by hours, and so we would divide from there. You can always round if the numbers don't come out very nicely. Part D asks what a student can expect their grade to be if they study 0 hours all semester. Well, plugging in 0 hours is not too bad. We just plug in 0 for the x value, and what we're going to get is that y-intercept. Part E says how much can a student expect to improve their grade for every additional hour they study. So looking at the difference between studying 0 hours and studying 1 hour, for example, would show us that every time we add a single 1 value to the x, the y value is going to increase by 0.6. That's the slope. That slope is what tells us the rate of change for each time there's an incremental improvement in x. So as x grows by 1, the y value grows by the slope, which is 0.6. So in other words, if a student studies 1 extra hour, we expect their grade to go up about a little more than 0.5%. Lastly, number 4 is a lot of your opinion, and I would love to hear your feedback on what it is. Do you feel there is causality between the variables? If so, explain why, and also specify the direction of causality. Remember that causality means that there's a causal relationship in there, root word cause. One caused the other to happen. Does spending hours studying for an exam, cause an improvement in your grade? If so, then yes, there should be some causality there. I would say certainly there is causality. The direction of the causality, though, is talking about which one influences the other. Does your grade in the class influence the amount of hours that you study? Or does the amount of hours that you study influence the grade in your class? And so those are different ideas, and it's important to know that we want to specify direction sometimes so that we know which one is the catalyst to change. So looking at my grade at the end of the semester is not going to make me study more during that semester because the semester's over. Really, it's how much effort I put in the beginning. So the direction is our studying leads to better grades. So not only when we're looking at relationships between two variables do we want to see if a causal relationship exists, but we also want to specify which one of those variables is causing the change in the other variable. Sometimes it's hard to determine. Sometimes the two just seem like they're working together and it's hard to split out that causality. Sometimes it's more apparent that we can see one of these causes the change and the other one is just changing. In this case, that's what's happening with our studying and our grade. So I'll leave the rest of this to you. Certainly write out your descriptions and your reasonings for 2F. Fill out the rest of your ordered pairs on that giant scatter plot. Make sure that it fits pretty closely to that line of best fit. When we come back next time, I'll talk a little bit more about just the variable things that can happen in this problem. There's a couple different ones that I wanted to look at, like in predictions and the limitations of predictions. I'll mention that after I post the key for this. Um, and we'll start in chapter 6 early tomorrow. The prep stuff in chapter 6 is a lot of mean, median, mode, measures of central tendency. We're going to do some pretty basic statistics in the beginning, and then we're going to step it up and talk about normal distribution. So if you want to get a head start on that, certainly. Otherwise, I expect you'll be listening to the video tomorrow. Hope you had a great day. If you have any questions, you know where to see me.